Okay, so we're going to continue where we left off from the last time. So this is, if you would, part two for our module two learning plan, which also, I'm sorry, module three learning plan, which also correlates to chapter three in our textbook. So in section 316, which is actually on page 60, if you wanted to open up to that section, you're going to notice that it talks about vector equations. Now, technically, we've been looking at vector equations. An equation is going to be when we have variables on two sides of an equal sign. So technically, when we say R is equal to, and we say A plus B, that's a vector equation, okay? And as we had seen before, when we were working with positives and negatives, they work very similar to some of the rules of algebra that we've learned as well. So, for instance, when we have a vector equation like we see here, if we have vector A plus vector B minus C is equal to D, you'll notice we have two sides of our equal sign. But as you remember, when we have a negative sign in front of a vector, it kind of makes it a little special. We have to do a little bit of extra thing. There's one of two ways that you can deal with it. You can either add those vectors, tip to tip is what the book reinforces most. But I also showed you another method, which they also showed, but they don't seem to use it quite as much, is when we actually add the negative value. Sometimes you might be like, I don't want to deal with that negative. If you can, the best way to handle that is to really just get rid of it and put that variable on the other side. So for instance, you'll notice here we have a negative or we have a minus C here. Since we have the second side to the equation, notice that we can rearrange that to subtract the C, add C on both sides, just like we would do in algebra. So we basically aren't really changing anything about this equation. All we did was rearrange it so that we wouldn't have the negative. Now what we have is we have A plus B on the left-hand side is going to be equal to D plus C. Both will result with the same answer or the same solution, okay? It's just that in vector addition or in vector equations, dealing with negatives, not that it's hard because we know how to deal with them, but if we don't have to, why not just rearrange it out, if you would? So in this case, notice that that's exactly what they did. And like they say, it's going to render the same result. Now, as we look to our next slide here and we jump over to section 318, section 318 is on page 63 in our book. And this is where we're going to be using the application of vector equations graphically, okay? So let's take a peek underneath our book here. And I'm gonna jump right into example 316 because this is going to kind of make a little bit more sense as we talk about things if we have vectors to actually reference. So as we can see here for example 316, we have a vector equation, all right? And our vector equation is right here. It's saying vector A plus B plus C is equal to D plus E, okay? Now, as we know, for each one of our vectors, to fully define the vector, we have to have two quantities, the magnitude and its direction, okay? So if we look here, there are two quantities that fully define A, two for B, C, D, and E, okay? Now, algebraically, if we want to solve a standard algebraic problem, we're limited to only being able to have one unknown, right? Okay, if you remember. If we have more than one unknown, depending if it's in a linear equation, we can maybe do something like substitution to solve for the two equations as long as they have the same two unknowns. But otherwise, we might have to use some calculus, okay? So algebra, once we get beyond more than one unknown, it gets a little bit harder or dicier or challenging to calculate for the unknowns. But when we're dealing with vectors, we can have as many as two unknowns in that equation, okay? Now, you will notice when we look at each one of these vectors down below, A and E look a little different, okay? A and E look a little different. So A, you're going to notice that it's showing a horizontal line, but it's dashed, and we don't have an actual quantity or an actual magnitude. So in this case, we know direction. We know it's a horizontal line that A is going to lie along, but we don't know where it starts and where it ends. Okay, so we don't know its magnitude. So that's an unknown. That's one unknown, if you would. There are two quantities for that vector. We know one of the quantities, but we don't know the other. Okay, so but B is fully defined. We know both magnitude, which is going to be our 100 inches per second squared. And we know that it's at a 30-degree angle in that direction up and to the left from horizontal. C is also fully defined, okay? Notice here that is 124 inches per second squared going vertically straight up. D is also fully defined. So you'll notice these three have solid lines. They've got a magnitude and they have a defined direction. Okay, so fully defined. But then E goes back to being a dashed line. So in this case, you'll notice that we can see that E is a vertical direction, but we don't know magnitude. So as we look at these 5 vectors, the 2 unknowns that we have here are the magnitude for A and the magnitude for E, okay? So, as I said earlier, with vector equations, that doesn't scare us. Having 2 unknowns is totally doable. But what we need to do is make sure that those 2 unknowns do not land on the same side of the equation. If they do, we've got to algebraically move them away, okay? So, let's look. Our equation here is A plus B plus C is equal to D plus E. So the 2 quantities that are unknown for us are the magnitude of A and the magnitude of D. And you'll notice the way that this is arranged right now, the equal sign in the middle here, we only have 1 unknown, magnitude of A on the left, and 1 unknown on the right, the magnitude of E. Okay, so right now, the way that this is set up is perfect. But there's one other thing that we want to consider when we show the order of the arrangement of the variables, or the vectors in this case, is when we don't know something, we want to put it at the tail end of our string on that side of the equal sign. Okay, so for instance, if we wanted to do it in the order of A plus B plus C, if we start with A, and let's say I put an origin right here, because we don't know how long it is, we don't have a tip to put the tail of the next vector, okay? So what that means is we can't start with A. We have to actually put it at the end. We have to start with the 2 that we know that are fully defined. So whether it's B or C, we just have to start with one of those 2. And then we're going to put A at the end, okay? So what they chose to do, you're going to notice, is on that left-hand side, they're going to start with B, then they're going to add C, 2 fully defined, and they put their, the one that has the 1 unknown as A. We know direction, but we don't know magnitude. We have it at the end. Then we have the equal sign, and then we start again with a fully defined D, and then 1 unknown for our E. So A and E are at the end, if you would, of the string on either side of the equal sign. Okay, so does that make sense to everybody? So again, you can have 2 unknowns, in this case, the magnitude of A, the magnitude of E. They have to be on 2 sides of our equal sign, which they are, they're separated. And then we also need to put them at the end of the string so that we start our vector equation with fully defined vectors, okay? And then once those are exhausted, we can add in the unknown ones. So let's go ahead and in AutoCAD, go through the process of solving for the magnitude of A and for the magnitude of E, given the equation that we have right here, okay? So first things first, just like we normally do, we're going to go over to AutoCAD and we're going to draw out what we know about these 5 vectors. So I'm going to go over here. And I just opened up my standard kinematic start file, just like we've been doing, you know, with our other problems in this module. And I am going to use my layers here for the different values. So anything that is fully defined, I'm going to put on my regular object line layer. Okay, that's going to just be my solid line. Anything that is undefined, so A and E, I'm going to put those on that green object 2 layer. Now we're not solving for a resultant in this case. We're going to be solving for the magnitudes of those two. So that's why, since those are things I'm going to solve for, I'm going to put those on the green layer. So I'm going to start with B, and I'm going to put on my line width and turn off my ortho. I know that B is going to be at 100 tab, and I need to put it at 150 degrees, which is going to be 30 from 180, right? See, there we go. And then I know that this is going up and to the left, so I will put my arrowhead on here, and then I'm gonna move my B so that I can label it, and I will scale it so it's maybe about that size. Okay. So that's B. Then I'm going to, down here, I'm going to do C, which is going to be vertical, so straight up, and that is 124. And at the end point going straight up, I am going to draw the arrowheads for C. Now copy my B over and rename it C. And then D is going to be at 150. And this is going to be -60. And put the arrowheads at the end there. Let's see. And we'll do a quick save as, and this is example 3_16. Just so I don't go over the top of my start file. I'm also going to get rid of my UCS quick. It's nice. Now, once I have these drawn, the next thing I'm going to do is I'm going to change my layer to a different color. So I'm just going to use my green. And I'm just going to draw a horizontal line. So put your ortho on, and the length is not important at all. And I'm not even going to put an arrowhead on it, but this is going to represent the direction of A. Okay. And then we'll be able to use like trim and extend if we need to in the equation. You'll see to make it the correct length. And then I'm going to do the same thing, but a vertical line, put it over here for E. And I'll label that as E. So no arrowheads on A or E, because all we are identifying here is going to be the direction, horizontal for A, vertical for E. Before we start putting it in place, don't forget we got to put our equation to represent the vectors that we're going to be doing. So I'm just going to copy one of the letters. And we know that we're going to be using the second equation where we have A and E at the end of either side of the equal sign. So B plus C plus A is equal to D plus E. Extend this. B plus, don't forget the greater than sign, because that's going to let us know that we have a vector addition here and not an algebraic addition. So there's our equation. Give everybody a chance to catch up here before we move on. All right, looks like most of us are all set here. So now what we're going to do is, just like we did in the past, we're going to identify an origin, and we're going to start on one side of the equation and start adding things together, crossing over that equal sign, doing the other side, and then finding where we have some intersections. So I'm going to start on the left-hand side of my equal sign with vector B, okay, vector B. Going to kind of go up in both directions. So I'm going to start back on my origin. So I usually just use object 1 as my origin. So that's what I'm going to use to draw that. And remember, it's just going to be 2 lines, horizontal, just to kind of make a crosshairs or an origin. Doesn't have to be perfect. And I'm simply going to move my vector B, and I'm going to take its tail, and I'm going to place it at the intersection of that origin that I just created, okay? I'm probably going to have to move my equation, so I'm just going to kind of just move it out of the way up here. Now, this equation says I'm going to add B plus C. So B is in place, so I'm going to move vector C, and I'm going to place its tail at the tip of B, okay? So right now we have those 2 in place. Now the third vector is going to be vector A. A, as we know, is just direction. So all I'm going to do is I'm going to move A, and I'm going to do shift right mouse button. I'm going to do nearest somewhere along the length here, just random. And I'm going to put it at the end point of C. Okay. Because I don't know if this is going to go to the left or to the right, unless you take a peek at our answer key in the book, but I'm not exactly sure, okay? So now what I've done is, on the left-hand side of my equation, I've added B plus C, and then at the end of C, I put the direction of A, right? Horizontal line. So I've exhausted everything on the left-hand side. I'm going to now work on the right-hand side of my equation. And if you remember from last time, I told you, always think of that equal sign as an origin, or as the origin. So now that I'm crossing over the equal sign, that means that I'm going to be starting back at the origin with the tail of the vector that is the first one on the right-hand side here. So I'm going to move vector D. Its tail is going to go at the intersection of that origin that I have down there, okay? And then I'm going to move E to the endpoint. So again, I'll do nearest somewhere along that length there. And at the end point of D is where we are going to place E, okay? I am going to move E on this side here. Okay, so now what we want to do is we need to find the intersection of A and E so that we can get their lengths, okay? And as you can see here, they are going to intersect, you know, up and to the right here of our origin. So all we're going to do is, I think I can do this. I should be able to do an extend. Oh, it's not. Oh, the extend can go up. The E will go up if you have something up there. If it doesn't, that's okay. And then I can extend here. Otherwise, you could use the grips and physically move it straight up or to the right. Then now I can do a trim. And then you also want to trim away past the tip of each one of those. Oh, I must have had a. Okay. So you should have something that looks like this. And I'm going to move my equation closer over here. Okay. Now, we have the intersections of A and E, but we need to identify their definitive direction, okay? So we have to put an arrowhead on the end point, whether it's to the left or the right on A, or up or down on E. Let's look at A first. You're going to notice here that the equation on the left-hand side says B plus C plus A. When we add vectors, remember they're tip to tail. So that means A's tail is going to be at the tip of C, right? So that means its arrowhead is going to be at the right-hand side here of A. Does that make sense to everybody? Okay. So I'm going to go back to my object 2 and my arrowhead for A. I'm going to make it a little bit larger just because it's one of my final answers, is going to be going to the right, right? It's because it's A plus B plus, I'm sorry, B plus C plus A. Okay. Then for E, we know that it's D plus E, so that means that E's tail is going to be at the tip of D, right? So its arrowhead is going to meet up at the tip of A here, which also makes sense because we need those to be equal to each other, right? Have the same net effect on either side. And then I'm just going to move E's label right about there. Okay. And I'll move my equation maybe right there. Okay, so now what I have is I have arrowheads on each one of those vectors that I didn't know the magnitudes for. I did know their directions, but to answer this question, I still need to know what is the actual magnitude, right? How am I going to add that to this? Yep, dimensions, exactly, right? So we're going to go to our notes layer, and I'm going to start with A. I'm going to put a linear dimension on my vector. And as we would suspect, our font is too small to see. So we're going to have to go over to Annotate tab, do that down arrow on the dimensions, go to Modify, make sure you're on the Fit tab in the middle here. And I'm going to start with 25. We'll see what that looks like. I honestly don't know. And yours might be different too, depending on how big or small your font was. So I'm going to set as current and close. It needs to be a little bit bigger because I want to make sure that when I do my screenshot that I can see it. Okay, that's important. There has been a couple that I've had to let you know that I need it bigger because I can't read it. So I'm going to modify. I'm going to go to 40. Yeah, much better. I don't know if I do I'm going to be fine with that. So you should get 161.6. Okay. Mine is a little bit off. The book says 160. Did you guys get 160? You got the 161? Yeah. I'm confident in that. So they must have, I don't know, they must have rounded, which is weird. So, or they must have gotten a little bit different answer. So 161.6 is going to be, our answer. And then we're going to do that very same thing for dimension E. So another linear dimension, endpoint to endpoint. I got 303.9. We got 306. Yeah. You got the same answer as me? Yeah. I'm confident in that answer. So 303.9 is the correct answer. So that answers what they were looking for. What are the magnitudes of A and E? And you can kind of see those things that we went through. First of all, making sure that we don't have any more than one unknown on either side of the equal sign. And then also making sure that whatever is unknown is at the end of the string of the vectors that we're, in this case, adding together on both sides. Any questions about example 316 right now? Okay, this will be then another add to your module 3 practice problems. Okay, so this will be your example 316. And then we have one more example to go over as a practice with these equations. And what I'm going to do is I'm going to stop our recording here, and then I'll come back with the last recording on that last example.